control and we'll add resource allocation to it. Resource allocation. So remember, we have discussed the congestion control mechanisms in the last class. These are the end-to-end congestion control mechanisms by discussing different variants of TCP. But this discussion is incomplete until we discuss resource allocation as well, right? So resource allocation and congestion control are basically two sides of the same coin. So it's very important to complete our discussion on congestion control by discussing resource allocation mechanisms. So first of all, let us try to identify that what is the problem of resource allocation that we want to discuss. What do we think? What is the problem of resource allocations? The problem of resource allocation is that how to effectively and fairly allocate resources among a collection of competing users or nodes. All right, so two things are important that we'll be focusing throughout this lecture is how to effectively and fairly allocate resources. But let's talk about first, what do you mean by the resources, right? What sort of resources we are trying to allocate? So when I say resources, so this means I'm talking about bandwidth of links, and the buffers on the routers or switches. Why we are interested in allocating buffers on routers or switches? Because here we queue the packets for transmission. So the buffers on the routers and switches where packets are queued for awaiting transmission. Right. So we are interested in fairly allocating, fairly and effectively allocating the bandwidth of links and the buffers on routers and switches. We are interested in this because packets contend at a router for the use of a link. What if there are too many packets? What if we have too many packets? What's the problem? Yes, if we have too many packets, so this means, number one, maybe packet experience increased end-to-end delay. So too many packets means maybe we end up having increased end-to-end delay, or the queue overflows and packets have to be dropped. Obviously, if you're sending too many packets, more than the queue of a router or switch, the queue will overflow, and then we have to drop the packets. So this means queue overflows, and the packets have to be dropped. Right. So this is the problem managing resources. But as we know, and we have discussed in the previous class, that most networks provide a congestion control mechanisms to deal with such a situation, right? Where we have, end-to-end delay, or where the queue overflows and packets have to be dropped. We have this congestion control mechanism to deal with such a problem. But remember, let me write it here. Remember that that congestion control and congestion control and resource allocation that we want to discuss today, and resource allocation are two sides of the same coin. Sides of the same coin. The purpose is to address this problem, means end-to-end delay, and if the packets are too much, how to make sure that packets are not dropped or dropped intelligently. And by the way, both these mechanisms, either we talk about this congestion control or resource allocation, both these mechanisms involve host and network elements. So both involve, in both mechanisms, both involve hosts and users and network elements. Network elements such as routers, but let me elaborate a little bit this network element detail that we've already covered. That if we want to control congestion, the end hosts are involved. Where we have variety of congestion control mechanisms. The end host will monitor the network, identifying a packet loss or duplicate acknowledgement as a trigger of or as a congestion indication, right? And will slow down the sending rate. But what do you mean by the network elements? So when I say network elements, this means I'm talking about various queuing disciplines. Right? See, we have not covered this so far in terms of congestion control. So various queuing disciplines, we can use these various queuing disciplines. Various queuing disciplines can be used to control, can be used to control the order in which packets get transmitted, and we can also make a decision that which packets get dropped. Right. So why we are interested to take our discussion of congestion control to the network elements, because in network elements where we have various queuing disciplines that we can make use to control the packets at routers or switches. By saying control, we mean that we can decide which packets will get transmitted and which packets get dropped, right? So this is an important decision. So before we move on, so let's talk about what do you mean by queuing discipline. So when I say queuing discipline, this means a queuing discipline basically it segregates the traffic, right? So it segregates the traffic to keep one user's packet from unduly affecting another user's packet. So what it does is basically it segregates traffic. Why? It segregates traffic to keep one user's packet from unduly affecting the other user's packet. So that's why we are interested in. So we don't want one flow to affect the allocation of or the transmission of the other flow. That's why we want to discuss a queuing discipline or the queuing algorithms. So this resource allocation that we are interested in discussing is partially implemented in the routers, switches, and the link inside the network, and partially in the transport protocol running on the end host. So let me summarize this resource allocation problem. So what we'll be doing here, the resource allocation means that we are partially implementing this. We will be partially implemented in the routers, switches, and links inside the network, and partially implemented in the transport protocol. Right? And obviously this transport protocol is running on the end host. So probably we have briefly covered this implementation of resource allocation in implementation of congestion control in the transport protocol at the end machines. But so the focus would be on partially implementing resource allocation in switches, routers, and the links inside the network. Let's talk about the issues in resource allocation. So the next thing that before discussing any specific resource allocation mechanisms, let's talk about the issues in resource allocation. So in the issues in resource allocation, we'll first talk about the taxonomy of the number one point that we'll discuss here is the taxonomy of resource allocation mechanisms. Taxonomy of resource allocation mechanisms. Since the resource allocation mechanisms differ, creating a taxonomy is a very difficult proposition for the resource allocation mechanisms. But we can have these three different types of resource allocation mechanisms. Number one, router-centric versus host-centric. Router-centric versus host-centric. So what do you mean by router-centric? So when I say router-centric, this means when packets are forwarded and selecting which packets are dropped. So this means the decision when packets are forwarded and selecting which packets are dropped. Which packets are dropped. And what do you mean by this host-centric? By saying host-centric, this means host observe the network conditions and adjust the behavior accordingly. And by the way, we have covered this in typical congestion control mechanism of TCP that was host-centric, where a host was observing the network condition and adjust its behavior accordingly too. So in this case, host observe the network condition and obviously it adjusts its sending rate accordingly. But important thing that I want to note here is that these both mechanisms are not mutually exclusive. Right? These two groups of resource allocation mechanism, either a resource allocation mechanism is implemented at a router, means it's router centric, and or host centric. These are not mutually exclusive. These are pretty much related with each other. So these two groups, these two groups are not mutually exclusive. It's very important to remember this. Okay, so this is one type of or category in taxonomy of resource allocation mechanism. The second is reservation based. The second is reservation based versus feedback based. Okay, so what do you mean by this reservation based? So by saying reservation based, based means that each router allocates enough resources. So this means that each router allocates enough sources or resources. And what do we mean by these resources? These resources means that we are talking about the buffers and our the percentage of the link bandwidth. Percentage of the link's bandwidth. Okay, so all the resources mechanisms based on reservation is basically demanding from routers to allocate enough resources for a packet transmission. These resources include buffers or the percentage of the link bandwidth. And then we have the feedback-based resource allocation mechanisms. Feedback-based. And we are talking about the feedback. This means the feedback is either explicit or implicit. So either we are sending explicit feedback or implicit feedback. Okay, and then there is another category here, the taxonomy of resource allocation, and it's called window-based. Window-based versus rate-based. Okay, both these flow control and resource allocation mechanisms, the purpose is to tell the sender that how much data is allowed to be transmitted, right? So there is a there are two ways to tell the host that how much data it can send on the network. Either we can use a window-based mechanism or a rate-based mechanism, right? So window-based we have already covered in the typical TCP end-to-end congestion control mechanism. So what do you mean by this rate-based? By the way, so the window-based we have already discussed in detail that a sender maintains a window that is based on the receiver's feedback or receiver's congestion, receiver's buffer space, and how based on this information at the network condition, a sender controls the sending rate, right? So what do you mean by this rate-based? So the rate-based is more suitable for multimedia applications. Multimedia applications that we'll discuss in quality of services in the next class, inshallah. So the rate-based is for many different multimedia applications. Why? Because the multimedia application tend to generate data at some average rate and which needs at least some minimum throughput to be useful, right? So that's why if we are dealing with the multimedia applications, probably resource allocation mechanism can use this rate-based feedback mechanism to control the sending rate of an application, right? And why we are interested in this rate-based for multimedia application? This is because these multimedia applications want at least some minimum throughput to be useful. Okay. Before we move forward and talk about some of the evaluation criteria for the different resource allocation mechanisms, let's talk about different service models that are being used in the networks for congestion control at the moment. So there are two types of service models. So we want to talk about the service model. There are two types of service models. Number one is called best effort. To conclude this, the introduction or the problem of resource allocation mechanisms, let's talk about the service model. So one is called best effort service model. So by the way, this we have covered in details, right? The best effort service model of TCP. What it does is that it implies that feedback is being used, right? Means such a model does not allow user to reserve network capacity, and this was precisely happening in TCP's congestion control mechanism. So it implies that that um, that the feedback is being used. And used for what? Used to control the sending rate of a sender or a node, or to control network congestion. Such a mechanism, of course, such a service model, does not allow users to reserve network capacity. Right, so this we have already covered. This type of service model is something that is used by TCP's end-to-end congestion control mechanism. And the second type of service model is called quality of service based service model. So this implies some form of reservation. So it implies some form of reservation, right? So it implies some form of reservation. This means what? This means this requires significant router involvement. This was not happening in our earlier discussion. We did not discuss any such mechanism where a router was involved in some sort of reservation. So this requires significant router involvement. What do you mean by this? This means router involvement such as queuing packets, queuing packets differently. Depending upon the level of the reserved resources, right? So so probably would more be interested in this quality of based service model when discussing the different resource allocation mechanisms. So